Every image an AI generates starts as pure noise, random pixels, completely meaningless. Then, step by step, the model removes that noise until a clear image emerges. This process is called diffusion. It sounds simple, but the mathematics behind it quietly revolutionized the entire field of artificial intelligence.
During training, the model learns by doing the opposite. It takes a real image and slowly adds noise to it, step by step, until nothing remains. Then it learns to reverse that process. Forward, destroy the image. Backward, rebuild it. Do this millions of times across millions of images, and the model learns exactly how images are structured at every level of detail.
But how does the model know what image to generate? This is where text comes in. You type a prompt. The model converts your words into a vector, just like RAG. That vector acts as a guide during the denoising process, steering the noise toward your exact description at every single step. Your words literally shape the image from nothing.
The engine doing all this work is called the U-net, a specialized neural network shaped like the letter U. It takes a noisy image as input, compresses it down to understand the big picture, then expands it back up to reconstruct fine details. At every level of this U-shape, it cross-references your text prompt, making sure every detail it rebuilds matches exactly what you asked for.
One problem remained. Running denoising across a full high-resolution image was extraordinarily slow and expensive. So researchers made a brilliant move. Instead of working in pixel space, they compressed the image into a much smaller mathematical space called latent space. Denoising now happens there, tiny, fast, and cheap. Only at the very end is the result decoded back into a full image. This is what Stable Diffusion actually does.
Researchers then asked, what if we gave the model even more control? Instead of just text, what if you could guide the image with a sketch, a pose, a depth map, or even another image? This gave birth to ControlNet, a system that locks specific structural elements while diffusion handles the rest. Suddenly, artists had surgical precision over AI generation. Diffusion models are not just generating images anymore. The same core idea, learn to destroy, then learn to rebuild, has expanded into video, audio, 3D objects, and even protein structures in medical research. What started as a way to remove noise from images is now rewriting the boundaries of what artificial intelligence can create entirely. But diffusion models are not without controversy. Artists worldwide raised serious concerns. Their work was scraped from the internet without consent and used as training data. The model learned their style, their technique, their years of craft, and now anyone can replicate it in seconds. This debate around AI and creative ownership is far from settled.
Diffusion models went from a research paper to reshaping entire industries in under 3 years, and we are still in the early chapters. If this series made you think differently about AI, subscribe, because the next topic we are covering will make diffusion models look simple. See you there.